All right, for number five, they said they're integers, x, y, and z, and they're members of a geometric progression. But the integers 7x minus 3 and y squared 5z minus 6 are members of an arithmetic progression. Find the integers x, y, and z. So I'm going to go to the whiteboard and try to figure out what's going on here. So a couple of things I want to write down. So the first thing I'm going to write down is I'm going to write x, y, and z. And again, they say they're integers, so these are integers, or part of these the big set of numbers integers, and they say they're geometric. All right, so at least I know they're geometric. So what does it mean? It means if I had x as the first term, the next term would be xr. I want to point out xr would be y, and the z would be xr squared. So kind of what I know about this, looking at it, I'm going to say I know that y squared. Right, this is the y squared over here, would be equal to this guy times that guy, because it would be x squared r squared. So I'm just going to say it's xz. So if it's geometric, it's going to fit that description. All right, that's one thing I know. It's called the geometric mean of it. Now what I want to do is I want to look at the other guy, which is they're saying that these things here, it's the same letters, x, y, and z. They're saying 7x minus 3, comma, y squared, comma, 5z minus 6 is arithmetic in nature. And for it to be arithmetic means that, basically what I got to do is look at these things and realize it's a common difference. Let me write this over here for you. So it'd be x plus d, x plus 2d. And there's a relationship between this term and the outer two terms. And what do? You just add those outer two terms together and divide by 2. Simple arithmetic mean, by the way. What would you get? X plus d. So let's write that down. So I'm going to say y squared is equal to the sum of the outer two terms divided by 2. And the outer two terms are 7x minus 3 plus, that's the outer term, 5z minus 6. I'm going to write this down, that y squared is equal to 7x plus 5z minus 9 over 2. All right? Now, certainly I have some things written down over here that are kind of important to me. I got this, and I got this over here. But I still don't know what x, y, and z are, but I know there's relationships over there. So what I would probably do is, kind of look at this and say, I could equate these two equations together, right? So if y squared is y squared, I could say xz is equal to 7x plus 5z minus 9 over 2. Now, someone says, what did that accomplish? I'm going to say a little bit, but not much. It got rid of one of the letters in the problem, and now I'm left with just x and z. So I want this over here. So 2xz equals 7x plus 5z minus 9. That's a nice thing to know, by the way. All right, so kind of looking at that, I'm wondering what to do about that. And I'm going to say, I can either get the x on one side or the z's on one side. I'm not sure what to do, but I'm going to try this over here. So 2x z minus 7x equals 5z minus 9. Then what I'm going to do, I'm going to factor out an x, and you get 2z minus 7 over 5, I'm sorry, not over, but 5z. I'll do that later, by the way. I'm kind of thinking forward on it. And I could solve for x now. What's x going to be equal to? 5z minus 9 over 2z minus 7. All right? So then the question is, what do you want to do about that? I'm thinking about that. I'm going to look back over here, see if there's anything else I could come up with. I got to think a little bit. Let me think. I got to multiply both sides by 2. So 2x equals 10z. This is just going to make it easier for me in the long run if I do that. Minus 18 over 2z minus 7. All right, I haven't changed anything. My question is, I know they're integers. I'm trying to figure out how I could figure this thing out. So we're going to get down 2x. And then I'm going to do long division. I'll show you what I mean by that. I'm going to erase it after I do it, by the way. I'm going to 2z minus 7. And this is my reason for multiplying both sides by 2, by the way, because I think it's going to make my division a little bit easier. So what'd you get over there? I'm going to say it's 5, because you get 10z. 5 times minus 7 is minus 35. So this is going to give me 5. And then I get a remainder. And let's do the remainder now. Let's see, 12, 17. So you can get plus 17 over 2z minus 7. All right, I'm going to get my eraser out and get rid of this thing over here. I don't need my long division anymore. All right, so what do I know? This is always the tough thing for me. I'm looking at this thing over here, and I certainly know 17 is a prime number. So then if it's a prime number, and I know that 2x is an integer, I've got to make that bottom number either 1, minus 1, 17, or minus 17. So let me see if I can do that. And again, the reason for that, I'm looking at this fraction, and I know these things are integers. The bottom number either has to be 1, minus 1, or it could be 17 or minus 17. Let's just try it like one at a time. Let's try z to be 1. I'm sorry, not z to be 1, the bottom to be 1. I misspoke. I don't want z to be 1. It could be 1. So I want 2z minus 7 to be equal to 1. And the reason for that, 17 divided by 1 is an integer. I want it to be an integer. So what I'm going to do over here, let's see if I can do that. That would be 2z equals 8. So that means z equals 4. That's possible. We'll go over that later, by the way. And I'm going to say 2z minus 7 could be minus 1. What would that give me? 2z, and I'm going to say minus 7, add 7 to both sides, I get 6. Z would be equal to 3. So I'm getting possibilities now. All right? We'll look at them later, by the way. Notice the difficult question, by the way. I'm also going to say it could be 17. So 2z minus 7 could be 17. And that's going to be 2z, add 7 to both sides, that's 24. So z could be 12. All right? I'll put a little check mark. It's an integer, right? 2z minus 7 could be minus 17. And my criteria are integers. And what's that going to be? 2z equals minus 10. That means z would be equal to minus 5. All right? So I think I'm doing okay. And I'm going to write this down now. So if z is equal to 4, what would x equal? Well, you remember, I'm doing it over here, right? I want to see if I can do that. It doesn't look that bad because the bottom would be 1. I get 15 plus 17. I'm sorry, 5 plus 17, which is 22. And 2 times what would be 22? 11. So x would be 11. That's okay. It's an integer. Let me do z to be 3. And we'll check this with the original wording of the problem. I'm just looking for cases, by the way. So we just did the 4. Now I'm on the 3. The 3 would give me minus 1, so minus 17. And 5 minus 17 would be minus 12, so x would be minus 6. Still an integer. All right, let's do z as 12 now. And again, I'm trying to figure out what x is. Now, if z is 12, remember, 2 times 12 is 24. 24 minus 7 is 17. 17 minus 17 is 1. You get 6, so 2 times 3 is 6. All right, let's keep moving. Let's put down z equals minus 5 now. Still an integer. What would x be? Well, the bottom would be, let's see, minus 17, so you get minus 1. 5 plus minus 1 is going to be 4. 2 times what would be 4 is 2. Right, by the way, I still don't know what y is. And I'll be writing these things down for you in a moment. All right, put them in the correct order too, by the way. So I want to see, do I know what y is? Well, I know what y squared is. It's just x times z. All right? So I know that y squared is x times z. Now let's do the first one. And again, I notice things, and certainly they're talking about arithmetic. So the arithmetic sequence would be x, y, and z. All right? So x times x times z would be 44. So y, let me see if I said it right, 4 times 11 is 44. So y would be root 44, which is 2 root 11. All right? Let me see how we're doing so far. Let's put the next one down. And the next one, I'm looking at 3 times minus 6. Well, that's minus 18, right? Y squared minus 18. Well, you know what? That's complex, by the way. Oh, by the way, this is not integer. It's not possible. No good. This one's complex, so I'm going to say no good. Let's do the next one. Let's do x times z. Well, that's 36, and that would equal y squared. Well, y could be plus or minus 6 now. We'll talk about that later, by the way. Certainly a possibility. Let's do the next one. The next one's, minus 10. And what's minus 10? It's really just y squared. And that's not a complex number. So I got a sequence over here. I'll put down what the sequence I have. And there's 2 of them. I'm not sure which one's going to be, right? So I could say 3, 6, 12. I could also say 3 minus 6, 12. I want to see if it's arithmetic, by the way. So 3 to 6, that's not working, is it? 3 to 6 is 3 up, and then 6 to 12 is 6 up. That doesn't seem to work. Let's do this one over here. And if I want 3 to minus 6, let me just see if I got that. So the z is 12, the y is plus or minus 6. Oh, you know what? They're not, I didn't say it was, I'm sorry, I misspoke here. Arithmetic, not arithmetic, right? X, Y, and Z are geometric. Sorry about that. I misspoke, by the way. I'm still looking at this one over here. This is my only possibility at this point, which can be 3. I'm going to say 6 and 12. The other one is 3 minus 6 and 12. And by the way, there's 2 things I'm going to check is the geometric. And look at that over there. This is geometric because I multiplied by 2. And this one's geometric too. I multiplied by minus 2. So they're both geometric. So both of these look good. But I still want to go back to this one over here and see if it's arithmetic. All right? And I have to remember where they were, by the way. Oh, it's right over here. So I'm going to write down 3, 6, and 12. I'm going to check it out now. So what'd you get? 21 minus 3 is 18. Y squared would be 36. 5 times z would be, let's see, that would be 54, right? Now, was that arithmetic? Are they going up by the same amount? 18 plus 18 is 36. 36 and 18, well, it's 14, 54. So this works. These work. Let's try to see if 3 minus 6, 12 works. All right, let's see if that works. Let's cross this out. What do you get? You get 18, 36. Yeah, you still get the same thing, 54. They both work. So there's 2 sequences that's going to work, by the way. So what could the answer be? The answer could be, whoops, I lost my track of that. What happened there? It could be 3, 6, and 12. It could be 3 minus 6 and 12. And we're done. It's the only possible answer that would work. Those 2, by the way. Thank you.